Hi guys, thanks for tuning in to another video. Before I really get into anything, I will just say that I borrowed some code from my PIC18F4525 series of videos where I blink an LED because I had a nice delay routine where I coded that, and there was an outer loop and an inner loop, and it worked well. So I just copied the delay routine bits for my new code. Also, you'll notice on my channel I have the PIC18F4525 video series, and in the last video I made on this chip, part 10 in this series, you can see I have this setup where I'm using the move FF instruction and I'm sending a whole byte of information out port D, and I won't re-explain that. And now this is the code I am going to be discussing today and demonstrating on my breadboard as well. So here is that delay routine I borrowed from my PIC18F4525 video, and I changed the names of the equates and the file locations, but it's generally the same. I'll try to get this through a little quicker. So port D is all output. Port C, all input. It borrows the move FF instruction from the last video, where R1 is sent out to the output port, which is port D. Then it bit tests a single bit or a GPIO pin, RC0, on port C. And if this pin is high, then this R1 equate GPR file RAM location is incremented, and it's incremented on this line. And it bit tests F, skip if clear, so it'll skip if the input on RC0 is clear, it'll just skip this and call the delay routine and then go back to the main. But if RC0 senses a high, say for instance when I press a push button and make input pin RC0 go high, then it won't skip the next line, it'll increment the next line. Then it'll call the delay routine, which for argument's sake is roughly about a second. Goes through the delay routine, and then it returns like here, and then it goes to main again, and then it moves this R1 equate file location to port D again, and then incrementing it each time. But what's going to happen is, yes, it is displaying this whole byte of information, which is stored in R1 and sent out to port D. That's just something it does, but the point is that it does it according to a delay routine, and I have it set up with a push button. So in effect what happens is when I push the button, it starts incrementing and outputting on port D. If I remove my finger from the push button, nothing happens. So when I push the push button, it starts counting from 0 to 255 in binary. When I take my finger off, it just stops doing it. So the point that I'm trying to make in this code is not to increment a byte of information and display it. It's just the fact that I can push a button, make something happen. When I take my finger off the button, that thing I'm doing stops happening. So that's pretty useful. Have I covered a similar topic in a previous video? It's possible I may have done that already, so this might be a duplicate concept. But anyway, thanks for watching, and I'm creating this video because it's easy to make, because I already have everything set up, so I'm cheating in a way. Thanks for watching.
Alright, so I have things set up similar to my last video. This is a little different. The code is still set up to increment when RC0 detects a high signal. Port C, all the pins, all 8 bits, are set up as inputs. Port D are set up as outputs. And an equate is being used to take a GPR file location and increment that by 1 each time the main loop goes through and detects a high on RC0. And in the R1 location, the move FF sends the data out to port D. Now the code is set up much the same way as a blink code, where there's a delay in between, but instead of blinking an LED, it's displaying GPR R1 and putting it out to port D. Now, I almost accidentally came across this idea when I was working on my last project, so I reassembled it so that I could give it a go. This is a pulled down resistor. It's currently set up with a pull down low on it, and when I push the button, it'll send a high signal and it will cycle through the code. And it's going about as fast as the delay subroutine will permit. But if I take my finger off, it stops iterating through the code. Because if I take my finger off, RC0 is no longer detecting a high input. So this is just a new twist on an old favorite, and it did something unique, so I thought I should make a video on it. Thanks for watching.